Imagine falling into a place where time itself begins to warp. As you plunge deeper into the darkness, you check your watch. Everything feels perfectly normal. From your perspective, the seconds tick by precisely as they always have. Back on Earth, the people watching you fall see a very different reality. To them, your movements become sluggish. The closer you get to the edge, the slower you appear, until you eventually freeze in place, locked in a single moment forever. This strange scenario comes directly from Albert Einstein's theory of relativity. He proposed that extreme gravity can physically warp the flow of time. These extreme time distortions leave the realm of theoretical thought experiments and become real physical consequences near the most massive objects in the universe, black holes. To understand how they warp time, we have to look at how they form. A black hole begins its life as a massive star, burning through nuclear fuel to maintain a steady outward pressure against its own weight. Eventually, that fuel runs out. Without that outward pressure, gravity takes over. The star rapidly collapses inward and detonates in a catastrophic supernova explosion. The outer layers are blown away, leaving only the core behind. It continues to compress, packing the mass of several suns into a space so dense that not even light can escape. That extreme density creates a gravitational pull so intense it breaks the normal rules of space. Let's travel closer and see what that gravity does to the reality around it. As we drift toward the black hole's orbit, its immense mass begins to drag on the surrounding space, pulling everything toward a central point. This chart shows the mechanics of time dilation. The top pulse represents time passing far away from the black hole. The bottom pulse shows your time as you move closer to the gravity well, stretching out and slowing down relative to the rest of the universe. As you sink deeper into that gravity well, those bottom pulses stretch to near infinity. From the perspective of someone watching from Earth, the time between your physical movements takes years. You appear permanently frozen. Time is no longer a universal constant. By pulling so heavily on the fabric of space, the black hole locks you into a localized eternity. The distortion of time is only one part of the danger. The physical threat to matter becomes much more violent as your proximity decreases. This diagram shows how gravity behaves across short distances. As you fall feet first, the downward arrows representing gravity are pulling significantly harder on your legs than the arrows pulling on your head. These differing pulls create intense tidal forces. The object is physically stretched into a long, thin shape, a process astrophysicists call spaghettification. Gravity dismantles the physical geometry of objects in this environment, tearing matter apart at the scale of atoms long before it ever reaches the center. If you survive the tidal forces, you eventually arrive at the edge of the void, the event horizon. Rather than a solid surface, it acts as an invisible threshold. It marks the absolute point of no return for any object in the universe. This animation shows why black holes appear black. These particles of light, or photons, are attempting to radiate outward, but the gravitational pull is so extreme that their paths are completely bent backward. The escape velocity here exceeds the speed of light. The event horizon is a one-way door. It is the ultimate cosmic prison, where even the fastest-moving particles in existence surrender to gravity. So, what actually happens to reality once something crosses that invisible threshold? Crossing the horizon leads to a region where gravity is predicted to squeeze matter into a point of infinite density. This extreme state causes the mathematical laws we use to describe the universe to fail, resulting in a total breakdown of our current physical theories. We can observe their legacy from the outside. We measure how they bend space, slow time, and trap light itself. The true terror of a black hole lies in the absolute mystery of everything we have yet to discover. They sit in the dark as the ultimate limit of human knowledge, marking a strict boundary line between the physics we know and the absolute unknown.